Hey guys, in this question, we are given that two wires are made of the same material and they have the same volume. And the first wire has the cross-sectional area A and second wire has a cross-sectional area 3A. The length of the first wire is increased by del L on applying a force F. So we need to find out how much force is needed to stitch the second wire by the same amount. This is a typo. So wire 1 has area A and length 3L and wire 2 has area 3A and length L. So we just need to use the formula for the Young's modulus and put the values there, and by the formula of Young's modulus we can say that the lambda L, that is the change in the length, is equals to F divided by A wire into 3L. And similarly for wire 2 we can just compare these formulas, which gives us F dash by 3A is equals to Y into del I by I, where Y is the Young's modulus. Since material is same, so Young's modulus will be same for the materials for the wires. So in this formula, this equation gives us the value of delta L, that is change in length, as F dash by 3AY into L. So when we compare both the values, we get that F dash is equals to 9F. So we need 9 times the initial force to change the length of second wire by the del L, that is the same length by which the length of wire 1 was changed.